Somewhere over the silent deserts of the American Southwest, under a sky darker than navy and colder than steel, a shadow streaked across the atmosphere. Too fast to track, too high to hear, too advanced to believe. For a moment, sensors went wild. Scrambled data streams flashed across satellite feeds. Air traffic control radars caught a ghostly blip. Then nothing. It wasn't a UFO. It wasn't a missile. It was something new. Something terrifyingly fast. In April 2025, the United States conducted a hypersonic test so stunning, so far beyond current expectations, that defense analysts, aerospace engineers, and even rival intelligence services were left scrambling to explain it. Faster than any known aircraft. Faster even than the mythical SR-72, son of Blackbird. The US had just crossed into the next era of aviation, and the world wasn't ready. To understand why this matters, you need to understand the legend the new craft is compared to. In the 1960s, the SR-71 Blackbird ruled the skies, a stealthy, titanium-built reconnaissance jet that could fly at Mach 3.3, over 2,200 miles per hour, and at altitudes over 85,000 feet. It outran missiles. It outflew enemies. It was untouchable. For decades, rumors circulated of a successor, the SR-72, a hypersonic plane supposedly capable of Mach 6. Blending turbojet and scramjet technology, capable of reaching anywhere in the world within an hour. A plane that could strike without warning, photograph battlefields in stunning clarity, and evade every known defense. The SR-72 was whispered about in classified circles, featured in science fiction novels, and shown as blurry renderings in defense presentations. But for years, it remained just that, a rumor, until now. In April 2025, at a classified test range, the United States Air Force and DARPA, in collaboration with Lockheed Martin's Skunk Works division, launched an experimental hypersonic vehicle under project name Darkstar X, a name insiders suggest was deliberately chosen to blur the line between fiction and fact. The vehicle achieved speeds in excess of Mach 7 over 5,300 miles per hour, stunning even optimistic projections. For perspective, at that speed, you could fly from Los Angeles to New York in under 30 minutes. Mach 7 is a wall that has long been theorized but rarely broken. It requires extraordinary engineering, special heat-resistant materials that can withstand temperatures above 3,500 degrees Fahrenheit, evolutionary engines that transition from turbojet to scramjet at blistering speeds, aerodynamic designs that minimize drag and manage airflow in a world where molecules themselves become dangerous projectiles. Darkstar X didn't just survive this realm, it thrived. Test telemetry showed the aircraft maintained stable flight for over 6 minutes at hypersonic speeds, performed banking maneuvers, and even achieved partial autonomous navigation, all without pilot intervention from the ground. For aerospace experts, it was like watching the future being born in real time. The implications of this breakthrough are staggering. Traditional air defense systems are built around predictable flight patterns. Even advanced missile shields like Russia's S-400 or China's HQ-19 are calibrated for ballistic trajectories or high-speed jets, topping out around Mach 3 or Mach 4. Nothing in the known world can reliably intercept an object moving at Mach 7. This means that with Darkstar X, or whatever final name the production version will carry, the United States could field a platform that is practically invincible. It could be used for reconnaissance, capturing real-time intelligence deep inside enemy territory before they even realize they've been observed. It could be used for strike missions, delivering precision-guided weapons at hypersonic speeds with no chance of interception. It could be used for rapid command deployment, shifting critical military assets across the globe in minutes rather than hours. And perhaps, most chillingly, it redefines nuclear deterrence. Hypersonic vehicles could carry conventional or nuclear payloads, strike without warning, and reset the entire balance of power almost overnight. But how did they do it? Insiders point to 3 major technological breakthroughs. First, a new class of adaptive cycle engines. Engines that can operate efficiently across a massive range of speeds, seamlessly transitioning from jet propulsion to scramjet operation once hypersonic velocities are achieved. Lockheed Martin's previously classified PDE pulse detonation engine research may have finally borne fruit. Second, metamaterials, heat-resistant composites so advanced they can absorb and dissipate the extreme frictional heat of hypersonic flight without melting or compromising structural integrity. It's rumored that portions of Darkstar X's skin can heal micro cracks autonomously, repairing damage mid-flight. Third, artificial intelligence integration. Advanced onboard AI that can manage navigation, engine control, heat distribution, and threat detection at speeds where human reaction time is simply too slow. In short, the pilot of a future hypersonic vehicle may not be steering with a joystick. They may be issuing mission objectives, and the aircraft itself will figure out the safest, fastest way to accomplish them. The world's response: panic, denial, and a furious attempt to catch up. China's hypersonic programs, including the DFZF glide vehicle, are impressive, but remain mostly in the Mach 5 to Mach 6 range. Russia's Avangard hypersonic missile can achieve high speeds, but it is not a reusable aircraft, and its maneuverability at sustained speeds is limited. Darkstar X changes the paradigm. It's reusable, manned or unmanned, rapidly deployable, and invisible to current radar arrays designed for slower threats. The Pentagon, while refusing to publicly comment on operational capabilities, has already increased funding to hypersonic projects across the Air Force, Navy, and DARPA divisions. Unofficially, defense insiders now believe the first operational hypersonic strike wing could be combat-ready by 2030, at least 5 years ahead of previous estimates. For adversaries, this means no warning time, no safe airspace, no secure base outside missile range. Everything becomes reachable and vulnerable in under an hour. But it's not just about war. Hypersonic technology, once matured, could transform civilian industries. Cargo planes crossing oceans in minutes, emergency medical evacuations from anywhere on the planet, space launches at a fraction of today's cost. The Darkstar X isn't just a weapon, it's a window into the next age of human mobility. That said, the risks are enormous. High-speed frictional heating still pushes material science to its limits. Autonomous navigation at hypersonic speeds remains unproven over populated areas. The geopolitical consequences of fielding such unstoppable machines are unpredictable and dangerous. Because in warfare, superiority is never static. It invites competition, it invites escalation, and in a world armed with nuclear weapons and unstable alliances, the idea of Mach 7 strike platforms roaming freely is both exhilarating and terrifying. As the desert winds carry whispers of the Darkstar X's test flights, one thing is certain: the future of air power isn't coming. It's already here, and it's moving faster than anything we've ever seen. In the skies of tomorrow, there are no second chances, no easy defenses. Only the fastest, smartest, most lethal machines will survive. And if the Darkstar X is any indication, the United States intends to lead that future at a speed no one else can catch, not even close. Would you also like me to create a voiceover paced version with cinematic timing, or a visual storyboard breakdown if you're turning this into a video?